Next speaker is Sue Manson, got the title of Project Director for the Humber 2100 Plus, someone we know very well in the area from the Environment Agency. Sue, really looking forward to flood resilience and nature-based solutions. Over to you. Thank you.
Thanks, Paul, and thank you, Darren, for sharing my screen. Can we have the next slide, please? Sorry, for technical reasons, Darren is kindly controlling my slides today because, yeah, we wanted some resilience. So today I'm briefly going to talk about the role of nature in flood resilience and touch on some examples that we've currently got around the Humber and also what we're planning to do under Humber 2100 Plus. Next slide, please. So flooding is a problem and we need to manage the increasing consequences. Recent investment in defences has taken place, but obviously you're keen to hear today that nature has a key role to play in that resilience. So the Humber is low-lying and the people who live here are at risk of tidal flooding from the sea. And most recently in 2013, we obviously had the tidal surge where there were devastating impacts, and the images on the left, you can see there in Hull itself. You can see the area at the bottom is around Saltmarsh and Goole Bend. So there were devastating impacts, over 7,000 hectares of land flooded. Since then, there have been great improvements to the flood defences to better protect, for example, Hull city centre, Hessle and South Ferriby. But if we're looking forward, sea level rise and storm surges mean that the scale of flooding we currently consider to be infrequent and extreme is going to occur more regularly and with growing consequences across the Humber floodplain unless everyone takes action and is prepared to adapt. But nature has a crucial role to play in creating that climate resilient Humber. And that's what I'm going to focus on today. Next slide, please. So the National Flood and Coastal Risk Management Strategy wants to see nature-based solutions as part of our resilience and to support our natural capital. And nature plays a role in managing that flood risk. And that looks different in different places. But in a tidal flooding context, which I'm focusing on today, broadly, areas of healthy habitat can play a role in storing water and in absorbing wave energy, making flood defences last longer. So just a bit of national context for you before I focus in on the Humber, which I know you're all interested in. So at the heart of the National Flood and Coastal Risk Management Strategy, the idea is that we need to move the nation from a concept of protection to one of resilience. So traditional flood and sea defences will remain important as part of that, but they're only part of the necessary toolkit to reduce the consequences of flooding when it happens. And it's all about the overall capacity of people and places to plan and respond, and importantly, recover from flooding. So part of a climate resilient nation is about being agile to the latest climate science, growth, changes to our environment and natural systems, but it's also about making greater use of nature-based solutions. And our evidence has shown that working with natural processes can reduce flood risk in smaller catchments for low magnitude, high frequency flood events. And it can contribute to reducing coastal flooding and coastal change. But it can also provide those additional local benefits that have been touched on today with blue-green access for local populations. So working with natural processes in the context of the Humber is different to the most commonly identified upper catchment management, where people are thinking about tree planting and grip blocking. In the estuarine environment, the measures we adopt are different. They have to be able to manage enormous volumes of water. And working with natural processes can include natural measures such as reed beds or restoring dunes and salt marsh, but also it can include more engineered examples. So I'm going to share some examples today in a Humber context, but broadly in a tidal flooding context, areas of healthy habitat can play a role in storing water and absorbing that wave energy, making the flood defences last longer. So that's one of the key things we kind of want to focus on. Next slide, please, Darren. So we often think about intertidal habitat as offering protection to the flood defences. And some recent work we've been doing looking at this shows us there's evidence that where we've got limited intertidal habitat, the defences are being damaged by erosion. So we're having to invest more money to repair those defences. So in terms of the longevity of the defences, that longevity is reduced where we don't have that natural system operating. So the image on the top of on the left-hand side of the screen, sorry, I got my left and right muddled up there, show that there's that green band of intertidal habitat, which can be seen, there's obviously some salt marsh in many places around the estuary, that's mud flats. But in this particular example, you can see there the defence is experiencing damage. We don't have that salt marsh in front there offering that extra protection, and that's the case along some of the north bank of the Humber, and we're looking at that more widely across the whole estuary at the moment. So salt marsh and mudflats help reduce and dissipate that wave and tidal energy and can extend their design life. So we're undertaking a piece of work at the moment looking in the longer term, looking at how we can slow down the rate of deterioration and increase the resilience of the assets that we do have around the estuary during floods, and providing advantage in terms of defence performance, extended design life, but also reducing that likelihood of future breach. And that's really important to the communities who live around the estuary. So, we've got nature and people working together there. So the presence of habitat not only is great for biodiversity, for carbon, for everything else, but it can potentially help save money as well when you're looking over the whole life of the asset. Next slide, please, Darren. So many of you will be really familiar with Oprah Flats. Many of you will have been there, will have heard previous talks on it. And it's a fantastic example of engineered nature-based solutions, I suppose. It's a fantastic example of storing water and achieving multiple outcomes. And it's also a fantastic asset in terms of showing how partnership working can deliver more and multiple outcomes for all. It's an important site. It was created, it was breached in 2006 with the creation of the managed realignment site. But actually, from inception to breach, it is at least 10 to 15 years prior to 2006. And it's been designed so that it allows tidal water to flood a large part of the site during a tidal surge or high tides, but the rest of the site kind of inundates on a daily basis, resulting in the development of a species-rich habitat of reed beds, salt marsh, wet grassland. We've got over 200 bird species and a fish nursery, thus protecting the integrity of the internationally important Humber Estuary Nature Conservation Area, but providing those other benefits alongside that. As I say, by storing water during extreme floods, it plays a key role for the Environment Agency in terms of helping manage that risk further up the estuary to thousands of people and nationally important infrastructure. But there are other spin-offs. It's great, as I say, it's great for biodiversity, and it's a great way to see how working in an engineered way, you can still deliver some nature-based solutions. Next slide, please, Darren. So just wanted to touch upon our Water for Farmers and Wildlife study, which you've heard about at previous conferences in earlier phases of the work. And it's a partnership that we're delivering in partnership with the RSPB. And it's investigating the potential for temporary wetlands to support wildlife and improve flood resilience, whilst also providing benefits to farmers themselves. So we're now in phase 3, which is the field scale trials. We talked to you earlier about those earlier stages of the work. And we've currently got temporary wetland field scale trials happening at 2 farms on the River Ouse and the River Idle catchments. And we're working with the University of York, who are going to be monitoring the water and soil parameters at each of these trial sites, alongside the RSPB, who are going to be monitoring bird species. We've already observed 9 different species of bird at the first site, and we're expecting outputs in 2023. And all of this evidence that I've just been touching upon now is going to feed into what we're doing with Humber 2100. So it'll inform those approaches for how we can manage long-term risk in the estuary. Next slide, please, Darren. And before I go on to talk about Humber 2100, I just wanted to remind everyone about the dynamic nature of the Humber estuary. It's a dynamic system and it will continue to change. So that's why adaptation is essential. What you can see on the screen there are some really early maps of the Humber estuary where you can see Sunk Island. It is an island. The Humber estuary flows around to the north of that from the 1700s. And then the lower image on the screen that you can see at the moment is from the early 1900s. And so we're coming back to the point to think about, we need to think about adaptation and resilience in nature. And that needs to be the heart of what we're doing as we think about a flood resilient future. So we need the right solution in the right place at the right time to work with that natural system and natural processes. Our coastal estuarine systems are predicted to be impacted by climate change and many other pressures, and change within that estuary is complex and it results from many factors, some of which we still don't fully understand. So improved understanding and early actions required to avoid lasting damage to these environments, their biodiversity, and the ecosystem services that they provide. And that can only be achieved by considering the interrelated parts of the system and how they fit together. So change is human and natural, and the recent past illustrates the dynamic nature of the estuary. Humans have reclaimed intertidal land for centuries, and we need to kind of try and work with nature and help as we're developing Humber 2100 to make sure that nature is at the heart of what we're going to be doing. So next slide, please, Darren. So looking forward and in conclusion, the Humber 2100 is going to set the future direction for tidal flood risk management, and nature is going to be integral to that. So the approach to nature and FCRM are adaptable. So Humber 2100 is a partnership of 12 local authorities and the Environment Agency, and we're working together to develop an ambitious new long-term plan for managing tidal flooding and sea level rise and to support sustainable development. The Humber estuary has already got some fantastic natural assets which have been created as part of the historic flood risk management activities, such as Oprah Flats, Paul Homestays, Kilnsea wetlands, and Skeffling that were currently under construction, touched on by Annette earlier. And so we're learning from our activities and acknowledging the important role of nature as well as the dynamic estuary. And the long-term needs of the estuary's natural environment are going to be embedded into any future approach for managing tidal risk, enhancing the ecological system ability to respond to pressures such as climate change. We want an approach that will deliver an approach to conservation that moves beyond protecting the status quo and seeks to improve the quality and function. The broader approach is vital if we're to address climate change and to restore nature. Nature has a crucial role to play in creating a resilient Humber. If we help nature to adapt, it will help us to adapt. Last slide, Darren. If you want to find out any more, there's the best ways to get in touch with us. And thank you for the opportunity to tell you a bit more about what we're doing.